Hello engineers, welcome back. In this video, we're going to start a new data structure which is called hash maps, and specifically in this video, we're going to look at unordered maps in C++. Okay, I hope you're ready. Let's get started. So in this video, we'll discuss all these topics. First, we'll see what is a hash map and how it's structured. We will discuss what is the difference between ordered maps and unordered maps. We will discuss how unordered maps are managed inside the RAM, and then we'll perform some operations and code it in C++, and then we will discuss some time complexities. Okay, let's get started. So what is a hash map? So hash map, hash map is a data structure containing key value pairs. So there are a bunch of key value pairs, and if you put them all together, we get a hash map. The most common hash map we see in the daily life is the dictionary, right? So let's say I want to see the definition of the word apple. I go in the dictionary, I look for the word apple, and then next to it, we find the definition, right? Some definition. And there are many such words like this in the dictionary. And if we put the whole thing in one thing, this can be a hash map, right? So a set of key value pairs is a hash map, right? And here in this case, we have seen apple, which is a string, and the definition is also a string. But this can be anything. So I can also do one and put the word notation of the number. Like I can do this and write 2. I can write the number 3 and then the word 3. This is also a hash map. So the key, the left side element is key and the right side element is value. So we are asking what is the word notation of 1, and we get these 3 letters. What is the word notation of 2? We get these 3 letters. So the dictionary or the hash map has some meaning. So in our case, the dictionary is, collection of words, right? In this case, this is a collection of numbers. So it can be anything. The key can be of any type, the value can be of any type, right? I can do reverse as well. I can put 1 in key and the number in value. This is also allowed. So a hash map can be a combination of any type of key with any type of value. And we use this for quick lookups. So if I want to look up for the definition of apple, I will just say, hey dictionary, give me the definition of apple. And I quickly get the definition, which is a fruit, right? And I can ask directly what is the word representation of the numeric number 2, and I get the word 2. Okay, so for quick lookups we use hash maps. Okay, now let's see what is the difference between ordered and unordered maps. So in the case of a dictionary, it is an ordered map, right? So if we look at it, when we see any dictionary, the sequence in which the keys are arranged is in alphabetical order, right? So APPLE and the next word, let's say banana, will always appear after apple. Banana will not appear before apple in a physical dictionary, right? So the order is maintained. This is ordered by key. And in the case of unordered, there is no specific order. I mean, you cannot guarantee an order inside the hash map. So if you are randomly requesting anything, any value can be returned. There is no sequence in it. So that is called an unordered map. Okay. So ordered map in C++, at least generally, ordered map is stored using a balanced search tree. Little advanced search tree with automatic balancing and things like that. But inside it is a balanced search tree. Whereas in the case of unordered, the elements are stored using a hash table. Okay, so we'll not discuss this ordered concept in this video. We will focus on unordered, when we will discuss how this hash table is looking like inside the RAM and things like that, right? So that is a quick introduction and differences between ordered and unordered. Now let's discuss how unordered maps are arranged in memory, right? So we have already seen the concept of a hash table before when we have discussed arrays. Somewhere here, yes, hashing, right? So we have seen the concept of hashing, collisions, and everything. So there is just a hash table which is an array with indexes, and we put elements in it, and we call it the hash table based on some calculation and hash function. So let's just quickly recap that. So there is a hash table. Let's say this is the RAM, and this is my hash table. So there are indexes and empty slots. So in order to store my hash map, I will make use of these indexes, and each index will be a pointer to a linked list. So if this is the index, this is pointing to a linked list, head of the linked list. So this is the head. And this linked list can have pointer to another node, and that node can have pointer to another node. So that's how a typical linked list works, right? And then there is null. And inside each node, I can put my key value pair. So if this is the node, I can put key, I can put value, and then I'll have the next pointer. Okay. So this is how a typical unordered map is placed in memory. So how are these indexes chosen? So these indexes are chosen based on some hash function. Hash function can be a simple function or it can be a complex function. So in C++, there will definitely be some complex function handling collisions and probing and things like that. But just to understand the concept of hash functions, let's take a simple, simple hash function where we are saying the index is given by the length of the key. So let's say I'm building a small hash map like this. So let's say I want to build such a hash map. So how would I do this? I am saying my hash function is given by the index is given by the length of key. So the length of the key, which means if there are 5 elements in the key, the length is 5. So index is 5. And here the length is 6. So index is 6. So here the length is 5. Here also the length is 5. So how will this be represented in our RAM? So let's take our RAM again. So let's say this is my hash table. Initially everything is null. Okay, inside the hash table nothing is there. And I am saying that my index is given by length of key. So if I want to put apple, I will go to the index 5. Now here I will create my first node. So this is my first node. It is carrying the key value pair of apple and 10, and then it is having a next pointer which is currently null. Okay. And then when I want to insert banana, I go to index 6. I check, is this empty? Yes, it is empty. So I can create my first node again. Here, I will put banana and 20 as the key value pair. And then there is a next pointer which is pointing to nothing. And then when we have guava, again the index is 5. So I come and check at index 5. Is there anything? Yes. So I go inside the linked list. So I try to reach the end of the list, and once I reach the end, I will create a new node and attach it to that. So this is my new node, guava 30. And now guava has a next pointer which is pointing to null. And then when I want to add mango, I will do the same thing. I go to 5, check that it is not empty. I reach to the end of the list, and then I create a new node and add mango there. So this is how a hash map is constructed inside the memory. Okay. So once we know the structure, it is very easy to visualize and discuss also the time complexities, as you know what is happening inside, right? What about the hash table itself? So the size of hash table is dynamic. What I mean by that is when we begin creating the hash map, there is nothing inside. And once we start adding elements, let's say I'm adding one element, okay, I'm adding second element, okay. When I need a new index, so the hash map is extended to accommodate new indexes. So how does that happen? So there is a new array that gets created, let's say with 4 elements this time, and this whole thing will undergo rehashing. So in our simple example, the index is given by the length of the key. This is a very simple hash function, but the hash functions are usually more complex in nature and don't necessarily are static like this. They're not dependent on the length of the key. Okay. So when we put this hash table for rehashing, we get the same result because our hash function is quite simple. But when it's a complex hash table, then every element will undergo rehashing, and then the new element will have different kind of hashing. Okay, it need not be the same. So this process is dynamic in nature and it is taken care by C++. Okay, so this is how the memory management happens for unordered maps. Okay. Now let's see how we can do all these operations. For these, we will directly jump into code now because it is very easy to explain there. But just to give you a quick structure, unordered map is part of a library called unordered map in C++. Okay, so this is a library. It contains all the useful methods and implementations for dealing with unordered maps. So how do we create one? We say unordered map. Just like we used to do with vector, right? What did we do with vector? We said vector of int v. So we said I'm using a vector of type int, which means all the elements in my vector are int, and the name of this vector is v. So this is the structure, right? So unordered map is also a similar structure, except that instead of one thing, we need to give two things. We need to give what is the data type of the key and what is the data type of the value. Let's say I want to build a typical dictionary. I will have string as my key, and I will also have string as my value. And then I can give it a name. I can call it dictionary, my dictionary or something. Dictionary 123, something like this. So if I want to build this piece, so what is the type? The key is string, but the value is int, right? So I can do unordered map string comma int, and I can call it fruit score or something. Okay, so that's how we create. So with this introduction, let's jump into code now. So I've created a new folder called hashmaps, and this is the first file, hashmaps.cpp. And here, this is the library that I spoke about. This is the unordered map library, which is having all the utilities that we need for managing maps. Right? So let's create a unordered map. So unordered map string int, let's say we are calling it fruits. So let's try to build the same example that we have here. Apple, banana, guava, mango. Okay. So now we have fruits. So how do we insert elements? So for inserting elements, we make use of the notation like this. So fruits of apple equal to 10. So let's try to understand what is happening here. We said fruits of apple equal to 10. So when we give this, so this is the case of adding a new node. When I give fruits of apple, it goes here, finds the index and checks for this entire list whether there is a key called apple. If there is a key called apple, then it will change the value. Otherwise, it will insert a new node called apple. Okay. So when I do fruits apple of 10, because there is no key called apple, a new node gets created. Now let's do the remaining fruits. Banana 20, guava. Okay. So this is how we can put elements into the map, right? Like now let's see how we can read from it. Reading is again simple. We can say fruits of apple, and this is how reading happens. When we say fruits of apple, the C++ goes through the hash function and gets the index for this key. And let's say the index is 5, and it goes inside the linked list and checks for the key called apple. When it finds apple, it returns the value of apple. Okay. Let's run this and see. So we get the value 10 back. So that's how we can make use of this notation to give any key and get the value from it. Now let's see what happens if we give an invalid key. Let's say I've given apple 2, and this apple 2 I know doesn't exist in the map. Let's see what happens. We get the value 0. So this is kind of the default behavior of the C++ unordered map. If there is no element with the key given, it returns a 0. Okay. So let's remove this. So this is how we can read. Now let's see how we can update. Now let's say I want to change the score of mango to 50. What I can do is I can simply do like this. Fruits of mango equal to 50. So like we discussed before, if there is any key called mango, it will update it. So mango, let's say the index is 5 for mango, it goes through the linked list and looks for the key called mango. Mango can exist or cannot exist. If it exists, then the value is updated to 50. Now this value has become 50. Okay. If there was no mango, then we would see that a new node is created and then 50 is attached to that. Okay. Now let's see how we can remove. Remove is also easy. We simply say fruits dot arrays, and let's say I remove guava. So what is happening in arrays is, because we are dealing with linked lists, it gets the index of guava, it goes through the linked list and finds guava, and it will remove the connections, right? We know this is a typical linked list removal. So first, before this chain is broken, this chain is retained. First, this is now pointing to mango. Next, the chain is broken. Next, the node is removed. Now, if we look at it from 5, we go to apple and the next pointer is mango and the next pointer is null. There is no more guava. So all this is happening inside this method called arrays. Okay. Now guava does not exist. So that's how we can remove. So let's see how we can iterate over the hash map, right? For iteration, we can use the for loop, and we need to know the concept of pair in C++. So there is something called pair, which has two things, first and second. So we use this to iterate over a hash map because we have key value pairs, right? So in our hash map, the pair is key and value. So we will make use of this concept. So how do we build this? We do use a for loop and we ask for auto pair on our map, and then we can use that pair like this, pair dot first and pair dot second. Okay, let's see how this will work. So as you can see, there is the number 10 which we printed up here. After that, we are printing mango 50, banana 20, and apple 10. And guava is removed from the list. Okay. So let's do the same thing before and after removal. So before removal, iterate before remove. Okay. Let's do a cout. And this is after remove. Okay. So before remove, there were 4 elements, and after remove, there are 3 elements. Okay. So order is not maintained actually. So we don't need to consider this as the right order. It is considered to be an unordered map. Okay. So that's how we can do all the operations on the unordered map in C++. So we have seen how to create, how to read, which is also called iterate. We can see, we saw how to iterate over the hash map for accessing each element, and we saw how to access each individual element as well. And we saw how to update, we saw how to remove or delete, and we also saw how to iterate. Okay. Now let's discuss time complexities. So for create, it can either be O of 1 or it can be O of n. Why? So when we are adding a new element, it can be added at the first node when there is an empty list, or it can be added at the end of the list, right? So if it is an empty list, it is O of 1, nothing to do. But if it is at the end of the node, let's say my all the keys are of the same length. I can have 10,000 keys of the same length, and I want to insert the 10,001th element. So it has to go through the entire list, find the end, and then insert it there, right? So that is O of n in the worst case. Okay, and read is also same. For reading as well, the average case is O of 1 because there may not be too many elements, but the worst case is O of n. If I want to put every hash element in the same index and I need to find the last element, then generally that doesn't happen. The hash functions are good enough to balance the indexes. But in the average case, it is O of 1, right? So for update as well, it is on an average O of 1, worst case O of n. Same goes for delete as well. So if the element is nearby, it is O of 1. Otherwise, we have to go through the entire list, find the last node, and in the worst case, it will be O of n, right? And iterate is O of n because we have to go through each element. Okay. So those are the time complexities. So you can visualize this when you see the RAM structure, right? We have to go through each element and do the operation. Okay. So this is an introduction to unordered maps, guys. So if you have any questions, do ask me. So in the future videos, we will try to practice this concept. Okay. So thank you so much for watching, guys. Don't forget to leave a like if you found this helpful. Don't forget to comment if you have any questions or suggestions. Don't forget to subscribe to the channel. Don't forget to bookmark the playlist. Don't forget to share it with your friends so you can be more helpful and they can learn as well. That's it for this video, guys. Thank you so much for watching. I will see you in the next one. Cheers.